Chemistry, this is another sample problem coming to you from Chapter 7, Section 3. In this sample problem, we're going to be calculating the molar mass of barium nitrate, BaNO3-2. During this video, I'm going to be referring to a 5-step process for calculating molar mass that is present in the video lecture, so make sure you watch the video lecture, take your notes, and then have that 5-step process open in your notes as you follow along. First step I'm going to take is I'm going to identify each and every element that is present in this substance. In this substance, there are 3 elements present: barium, nitrogen, and oxygen. Next step, I'm going to go to the periodic table and identify the average atomic masses of each of the elements present. And I will record that, write that down. So barium's 137.33. Nitrogen is 14.007, and oxygen comes in at 16.00. Next step, I want to take into consideration how many of each of these elements are present. Looking at the formula, I see that there's only 1 barium. I see that there are 2 nitrogens because there are 2 nitrates. Each nitrate has 1 oxygen, or sorry, 1 nitrogen, I'm sorry. And then for oxygen, I see that each nitrate has 3 oxygens, and there are 2 of them, 2 nitrates, so there are actually 6 oxygen atoms altogether. Or 6 moles of oxygen altogether, I should say. Next step, I'm going to multiply these to get the mass due to each element. So I'll have 137.33 due to barium. I'll have 28.014 due to nitrogen, and I'll have 96, I believe, due to oxygen. Next step is addition. I'm going to sum all of these values together. So I'll use my calculator for some help. Calculator tells me 261.344. Now the appropriate units for molar mass are grams per mole, so you might be tempted to just slap those units on there and call it good. But we will have not taken into consideration how many significant figures we need to use when recording our final answer. The rule when adding or subtracting, but we're adding here, it's going to be the same in either situation. We're going to consider how many digits are past the decimal point in each of the values that we are adding. So here we have 2 digits past the decimal, here we have 3 digits past the decimal, and again we have 2 digits past the decimal. So 2 digits past the decimal is our lowest number of digits, and so 2 digits past the decimal is what my answer wants to have, or should have. This 4 indicates that we are not going to round this 4 up. We're actually going to keep it the same. So the value that I'm going to record for my final answer here is 261.34 grams per mole.